Today's recording is going to be formula mass, and formula mass is going to be a really important thing that we need to get under our belt and review again, because this is how we determine the molar mass for a particular compound, and we're going to need that later to go ahead and compare moles, which again, for a lot of this first stoichiometry section, we're going to be more concerned with comparing moles than any other thing. So with a formula mass, what we're going to do is define it first as the mass for a compound or a salt. It has other names that it can go by as well, which include molar mass or molecular mass. And it is found by adding up the average atomic masses of all the elements that are in a compound and making sure that we have them in the right proportions. To determine molar mass, we're going to first figure out how many of each element that we have. Next, we're going to multiply the amount of each element by the molar mass, or the average atomic mass of that element. Then we're going to go ahead and add the relative masses of each element in the compound together, and that'll give us our total molar mass or formula mass. So let's go ahead and start with iron 3 oxide. And iron 3 oxide, we can see here that we have 2 irons and 3 oxygens. So we're going to go ahead and multiply both of those by the molar mass of their constituent atom. In the case of iron, we'll multiply it by the molar mass of iron, and oxygen will be multiplied by the molar mass of oxygen. Iron's molar mass is 55.845, and oxygen's is 16. When we multiply those together, we get a total of 111.69 and 48. And then we add those together to get 159.69, which is the molar mass or the formula mass for iron oxide. Now, this is also going to be something that works with a larger compound. In this case, I have found the chemical formula for remdesivir, which is one of the chemical compounds that's been floated around to help treat COVID-19. And remdesivir has a chemical formula of C27H35 N6O8 and a single phosphorus. So it will end up being set up the exact same way. It doesn't matter if it's a large compound, a small compound, it all ends up being the same thing. We're going to find out how many of each one that we have, and then we're going to go ahead and multiply it by its molar mass. When we do that, we get all of our relative masses, we add them together, and we get the molar mass for this compound. The reason that we are able to do this is because of a particularly hideous gentleman named Avogadro. And Avogadro was able to help to determine this proportionality between a single element and a mole of an element. And his ability to do that kind of led us to further dissect what's going on with stoichiometry. And for this review, there's a couple of things that I want you to note in particular. First is that he determined that 1 mole of a compound, and mole is kind of like our workhorse unit for chemistry. 1 mole of a compound is going to equal 6.02 times 10 to the 23rd molecules or atoms or formula units. It doesn't really matter what. If you have 1 mole of something, that means that you have 6.022 times 10 to the 23rd. Okay? And that number is called Avogadro's number. And this is just a way for us to go ahead and take specifically that atomic mass that we find on the table, which is supposed to represent an element, and turn it into something that's measurable for us. So because we're going to be working with a large volume or a mole of atoms or a fraction of a mole of atoms at a time, we can now use the average atomic mass in such a way that we can accurately determine how much or quantify how much of a compound that there is. Now, because of his discovery or his experimental techniques, we have a direct way to go ahead and compare different quantities of the atom. And the three different things that we can go ahead and compare are particles, grams, and liters. And this is in particular liters of gas. So, as I said before, the main workhorse that we're going to be concerned with is going to be that mole that's in the center. And if we have our mole of compounds and we're trying to get it to a measurement, and let's say that we have solid particles. If we're trying to go from moles and we're trying to measure solid particles, well, the only way we're going to be able to measure solid particles accurately is by using grams. So we can go ahead and multiply the number of moles of a substance that we have by the molar mass, and that will tell us how many grams we have. And likewise, sometimes we might have a certain amount of a substance measured in grams, and we may need to find out how many moles that we have so that we can compare it to another substance. And we're going to do that by dividing by the molar mass. The other really useful one is when we're talking about gases. And gases, especially when we're at standard temperature and pressure, have a set amount of volume that they inhabit. And 1 mole of a gas is going to equal exactly 22.4 liters. So if we wanted to say that we had 1 mole of a gas, we can multiply that by 22.4 to determine, hey, that 1 mole of gas will take up 22.4 liters. Likewise, we can also take how many liters of gas that we have and divide it by the number of moles by 22.4 to determine the number of moles of a gas that we would have. The last one is converting it in particular to particles. So going from moles of a substance to particles of a substance. And this one is, to be perfectly honest, more of a conceptual thing. It's not very often that you're going to be doing real life chemistry where you have to convert from moles to particles, but it is another leg of this diagram that you should record and make sure that you have information down for it. Most often what will happen in chemistry is that we're going to be concerned with converting from moles to grams and from grams to moles. That one's going to be the most useful one. The secondary most useful one is going from liters to moles, because that's taking measurable amounts to something that we can compare to other substances. And every once in a while, we're going to go ahead and go from grams to moles to liters, which just means that we're going to be doing twice as many conversions. So this mole map, I'm going to want you to have recorded in your notebook so that you can go ahead and do some of the practice problems later.